Hello there, everyone. We start off with our third class of the chapter Sequence and Series. And in this class, we are going to talk about geometric progression part 1. So basically, we are just introducing the topic of geometric progression in this class. And then in the next class, we will be talking about some other properties and other stuff regarding geometric progression. So to begin with, a geometric progression is basically a sequence where the consecutive terms have a common ratio. So if, for example, if I take numbers which are of these form, the first one being a, then the next one being ar, then ar square, ar cube, and so on, where obviously a is termed to be the first term, as we know of arithmetic progression, and r is the common ratio. So you can see if you just divide any two consecutive term, you are always left with r. So therefore, r here is the common ratio, which is just like the case of arithmetic progression, but there we had a common difference. So in the same way, the nth term in a GP or geometric progression is given by ar to the power n minus 1. So simple enough. So that's how we deal with the problems regarding geometric progression. And if there are three numbers a, b, c, and if we know that they are in GP, then we can establish the fact that b square is equals to ac. So you can definitely work out the way, by taking the three numbers as a by r, a and ar, and you can see that a square, that can be written as a by r into ar. So that proves the fact that if ABC are in GP, then b square is AC. Fine. Now let us move to the problems to start off with. Number one, to start off with a very simple problem, determine the 12th term of a GP whose 8th term is 192 and common ratio is 2. Now, this is a problem which you might have done in your junior class. The class in concern is class 10. So, to begin with, we are given the common ratio, so that is r, which is 2, and the 8th term that is given to be 192. So what is 8th term? Basically it is ar to the power 7, a being the first term. So therefore, solving this, as we know the value of r, we get the value of a as 3 by 2. So once we know the value of a and once we already have the value of r, then it is easy for us to find the 12th term. So the 12th term is ar to the power 11, and if you just do your calculation, you get the value as 3072. Number 2, if a square plus 2, a cube plus 10 are in GP, then find the common ratio of the GP. So now, to find the common ratio of the GP, first let me find out the terms of the GP. So to begin with, as I told you that if three numbers a, b, c are in GP, then b square is equals to ac. So therefore, the middle term whole square is equals to product of the other two terms. Now all we need to do is solve. So let us go on solving. And solving this, we get the value of a as 2 or half. So if the value of a is 2 or half, then what are the terms in the GP? So if I take 2, then the numbers will be 2, 6, and 18. And if I take half, then the numbers will be half, 9 by 4, and 81 by 8. So from the two different GP that we get two different common ratios, and the common ratios are either 3 or it is 9 by 2. Fine. Next, number 3. Number 3. Three numbers are in AP and their sum is 15. If 1, 4 and 19 are added to these three numbers respectively, then the resulting numbers are in GP. So find the numbers. So you can see this is a question where both the ideas will be utilized. So at first it is said that the three numbers are in AP. So let me consider the three numbers as A minus D, A and A plus D. Now the sum is given to be 15, so from there I can write that sum of all these three numbers is equal to 15, and from there solving I get the value of A as 5. So therefore the numbers are, for time being, 5 minus D, 5 and 5 plus D. Now what I am doing, I am adding 1, 4 and 19 to this. So if I add 1, 4 and 19 to this three numbers, they become a GP. So once I know that these numbers are in GP, so all I can do is use the idea that if three numbers are in GP, then B square is equals to AC. So using that, solving, I get the value of D as 3 or minus 21. So given that I am getting two different values of D, then there will be two different series or two different set of numbers, and the set of numbers are either 2, 5 and 8, or it is 26, 5 and minus 16. Right? You can just back calculate by adding them up and then adding 1, 4 and 19 and checking if they are actually in GP or not. So do that. Next, number 4. There are four numbers such that first three are in AP and the last three are in GP. The sum of the first and the third number is 2, and that of the second and the fourth is 26. So what are these numbers? So it's a pretty interesting question. There are four numbers in such a way that the first three of them will be in AP and then the last three of them will be in GP. Now, as it is mentioned that the first three are in AP, so we can consider the first three as A minus D, A and A plus D, right? So given that, it is also given that the sum of the first and the third is 2. So therefore, if I add the first and the third, I get the value of A as 1. So that gives me one of those numbers. Next, let us consider the last three numbers, that is the second, third and fourth number, to be A, AR square, AR and AR square. So as they are already told that they are in GP. Now, given according to the problem, the value of A that which we had, we already have found that value, and that is 1. So therefore the numbers are 1, R and R square. Now it is told that the sum of the second and the fourth is 26. So therefore 1 plus R square, that is equals to 26, and that gives you R as plus minus 5. Now once I know the value of R as plus minus 5, that will help me find the second, third and fourth number for sure, but also at the same point of time I need to find the first one, and for that I need to find the value of D. So to do that, if I consider R as plus minus 5, then A plus D will be plus minus 5. So I have forgot to put here that plus minus symbol, which I always do in every place. So that case, if I have this plus minus sign, if I take plus ones, I get the value of D as 4, and if I take minus ones, I get the value of D as minus 6. So given this, I will have two different sets of number. So let us start understand how we are doing it. So if D is 4, then A minus D, that is 1 minus 4, that is minus 3. So the first number is minus 3. Then the second number is 1, which we have already found out. Then the third number, remember from where we started, the third number is 5, and the fourth number, that is 25. So that is the first one. And in the second one, the same way, if I take d as minus 6, then 1 minus of minus 6, the first one is 7, then the second one is 1, the third one is minus 5. Remember, we took r as minus 5, and then obviously the fourth one is 25. So therefore, these are the set of numbers where the first 3 are in AP, the second 3 are in GP, and along with that, all the other conditions that are given are satisfied. Fine. Let's go to number 5, and which is the last problem for this class. Now this is a problem which is a pretty basic problem. The problem says that if pth term of a GP is P and qth term is capital Q, then prove that nth term is P to the power n minus Q by Q to the power n minus P whole to the power 1 by P minus Q. Now, whenever I've been given a GP, what I need to do, I always need to consider the first term and the common ratio. So the first term be A, the common ratio be R, and we begin. So what is capital P? Capital P is A r to the power P minus 1, and capital Q is A r to the power Q minus 1. So all I need to do is use these two values into the expression, and then all we need to do is we need to solve it. So we just put it into this expression and we go on solving, and if you go on solving, you will come across something like this, and you end up with A r to the power n minus 1. Now if you just remember when we started, A r to the power n minus 1 is basically the nth term, so which proves our required statement. So that's it. That is our class. And as always, if you have any doubt, please get it clear. Thank you.